Okay, continuing on with triangle congruence proofs. We have two more, the side angle side and the hypotenuse leg triangle congruence. So as the name suggests, side angle side, you need two sides and one angle. However, the most important thing is that that angle has to be inside of the two sides that you know. So it's got to be almost like sandwiched inside of your two sides. So it's an included angle. The two sides that are congruent create the congruent angle. So are these triangles congruent? Do they have the ingredients we need to make the cookies? We know side, side, side. We now know side, angle, side. So those are the two ways so far that we can prove triangles are congruent. Now, if we look right here, I see that I have side BC is congruent to side DC. I see that we have CE and CA. And then the cool thing about these angles right here, angle ACB and angle ECD, is that they are vertical angles. Do you remember those? Vertical angles. So we use vertical angles to prove that they are the same angles all the time. So yes, by side angle side, we can prove it. Now, if I look at this example, okay, what do I know? AB is the same as CB. I know that this is a right angle and this is a right angle. Therefore, they have to be the same. And then we also, what we like to look for vertical angles and we like to look for shared sides. So because this side is shared, line segment DE is going to be congruent to line segment DE, which is what we wanted. So this does have side angle side. So they don't have to be together. They can be separated or they can be connected and potentially share either an angle or a side, something like that to help us. So let's take a look at this proof here. C is the midpoint of segment AD and segment BE. So that means that AC is equal to DC and CE is congruent to BC. And we'll prove that in our statement here. So C is midpoint of AD. So I'm gonna just do 2. Yeah. C is midpoint of BE. And now I'm going to say that segment AC is congruent to segment DC. Now, again, you got to kind of be careful. The order does matter. So, again, think about what we're trying to prove. Our goal is to prove this. So I'm saying AC is congruent to DC. And that is by the definition of a midpoint. Because it was given to us that it was a midpoint, we know this to be true. And the same goes for BC and EC. Segment BC is congruent to segment EC, I believe it was. And same deal, definition of midpoint. And now all I got to talk about is if we're using side angle side, I got to figure out something to do with this angle and this angle. So again, the order of that you put the letters matters. So I'm going to say that angle BCA is congruent. So BCA, that's going to be ECD, is congruent to ECD. And that is because of vertical angles. So we say the vertical angles theorem, which is you can shorten it to VAT, vertical angles theorem. We know that those are congruent. So we now have enough information. We've proved two sides and one angle that's included is congruent. So we can say that triangle, again, just copy this. The order of the letters matters, so just copy it. And that is by the side angle side property. Hypotenuse leg. So special note, this again only works for right triangles. And if the hypotenuse, so across from the right triangle, and the leg, one of the legs, are equal to each other, then the two triangles are congruent. So if we look at this statement, given segment WY is congruent to segment XZ, so let's highlight that. WY congruent to XZ. Okay, given. I have WZ is, this means perpendicular. Okay, given. So let's see here. WZ is perpendicular with ZY. So that's a 90-degree angle right there. And XY is perpendicular to ZY, which gives me, oops, it's not rounded. Should be squared off more. This is a right angle here. Sweet. So I've got a 90 degrees and I do have my hypotenuse. So now I just got to figure out, can I prove one of the legs is congruent? Now remember, I'm trying to prove WYZ is congruent to XZY. Now notice I highlighted one part twice, ZY. So we have a shared side in our triangle. So I'm going to say that ZY is congruent to ZY because of the reflexive property. And because the order is a little bit different here, see this? I'm going to go ahead and I'm going to state that ZY is congruent to YZ. And if you remember, that is the symmetric property. Symmetric property tells us that we can switch that up and it's still going to be the same. So now I've done enough because I've proven that, hey, I have a 90-degree angle and then they share a side. They share, the hypotenuse was given. I was given the hypotenuse and then I found one of the legs to be congruent. So therefore, triangle WYZ is congruent to triangle XZY by the hypotenuse leg theory.